So we've got in question 7 to solve this equation. Now obviously we could do this with the calculator. Worth bearing in mind it could be a show that in an exam, for example. So let's just think about how we could solve it. We could use the quadratic formula. We could complete the square. Okay. So z plus 1 squared plus 9 to get it up to 10 equals 0. So z plus 1 squared equals negative 9. Z plus 1 equals, we still need the plus or minus. Square root of 9 is 3, and it's going to be imaginary, because it's negative, so 3i. Z equals negative 1 plus or minus 3i. Right, it then wants the modulus and argument of each root. So to do this, I do like to do just a quick sketch, so I can check. So we've got negative 1 plus 3i, somewhere up there. And then we've got negative 1 minus 3i, which will be somewhere down there. Really should be vectors. Right, this means that's going to be the argument there. And this one, we've got the argument there. Right, the modulus is going to be the same for both of them, because they both, if you imagine a triangle, they've both got sides 1 and 3. Okay? So let's call roots z1 and z2, call them whatever you like. Modulus of z1 equals modulus of z2, so that's the square root of 1 squared plus 3 squared, so that's root 10. Right, as for the argument, we can look at the red triangle. So we've got the angle there. Right. Now that angle there is going to be inverse tan, so tan is opposite over adjacent, so inverse tan of 3. Now we want for the root which has got plus 3i, we want this angle here, so let's call z1 minus 1 plus 3i, which is in that start, z2 equals negative 1 minus 3i. So the argument of z1 is going to be 180. Oh, they usually do it in radians actually, thinking about it. Okay, so we normally work in radians, so that means 180 is pi. Take away the inverse tan of 3. So in our calculator, oops, let's just check. So radians mode is shift setup angle unit radian. Okay. So pi subtract the inverse tan of 3 gives us, so give us 1.89 to 3 significant figures. And then if you look at, I've called this one Z1, this one Z2. If you look at Z2, the angle is going to be the same size, but this time we're going below the real axis and also in a clockwise direction from there. So the argument of Z2, so we go that angle there, is just going to be the same size, but it's below the real axis, so it's negative 1.89 to 3 significant figures. We can, again, you can check those in your calculator. If you go into complex number mode, one of the options is the argument. So, for example, negative 1, take away 3i, okay, and you can see that our answer is correct.